Okay, so today we're going to be practicing with the vertical line test and exploring domains and ranges with functions. We're going to do a few problems, so something like 6 problems today. And for each of the problems, we're going to do the following. We are going to decide whether it's a function or not. We're going to answer yes or no. We're going to talk about why. Then we're going to talk about expressing, writing down what the domain is and what the range is. All right. So we drew a sketch on our paper. This is an example of something we're deciding whether or not is a function or not. Is it a function? Yes or no? Yes. Why is it a function? Let's justify our answer. Yes. How'd you know it was? And that's called passing what kind of test? Perfect. So when you are deciding whether a picture is a function or not, you should use something called the vertical line test. Let's justify our answer. So we said yes because it passes the vertical line test. Anytime on your Regents exam, on my exam, that I ask you to justify your answer as to why it's a function or not, please write this down. Let's illustrate the vertical line test real quickly so that everybody understands what it is that we're talking about. The vertical line test says the following. Take a vertical line, could be a pencil, couldn't be your hands, and sweep it through. If it only touches the graph once at each point in time, it's a function. And in this particular case, that's what took place. Let's rephrase. So we were talking about the domain, and we tried to figure out what x values work in this equation. Some people had some good suggestions. You know, maybe it was between -2 and 2. It turns out you can sweep your hand through this graph, and all the x values work. There's nothing that stops it. The domain is not restricted. In this particular case, since everything works from -infinity to infinity, we could say that the domain is all the real numbers. And we could write this down by putting a soft bracket on -infinity, comma, infinity, another soft bracket, because infinity can't be caught. So same thought process goes for trying to figure out what the range is. But think to yourself, okay, so does the graph stop anywhere in terms of the y values? Yeah, it stops down at -2. So -2 is the lowest y could be. Does it stop anywhere above it? No, because of the arrows on this red graph. And so we say that, whoops, y is greater than or equal to -2. Another way of representing that using set notation is to put a hard bracket on -2 because of the greater than or equal to symbol, and saying that it goes all the way off up into infinity. Okay, so let's talk for a minute. What do you think? Is this graph a function, yes or no? No, it's not a function. Very nice. And if you had to justify your answer, what would you say the reason is why it is not a function? Skolnick? Yeah, no, because it fails the vertical line test. Perfect. Okay, so we're talking about domains. The domain of this function is what? Yeah, x. If you sweep your hand through, think about the domain are all the x values. So if you were to start your hand over on the right side of this graph and sweep it along, look, because it has these arrows, it means nothing is stopping it. So you're going to find an x value over in that direction that corresponds to the graph. But you keep going, you keep going, you keep going, and then eventually you get down to this point. That's the end of our graph, which means that's the lowest point possible in the domain. That's the end. So the domain must therefore be the fact that x has to be greater than or equal to that point. Now you could say it using interval notation, or you could say it using set notation. Because we have a greater than or equal to sign, it's going to be a hard bracket. And it goes off to infinity. Soft bracket around that one. Let's do it again. So we're finishing off this problem. Now we're up to part C. If I could draw. Part C, the range. All right. The range are the y values. What's the range of this graph? Yeah, nothing stops this graph. Nothing stops this graph at all. Nothing stops it. It never ever ends in the y direction because of those arrows. So what we could say is that the range of this graph are all the reals, and by reals I mean real numbers, or you could say to yourself, you know what? This thing goes from negative infinity to infinity. Soft brackets because we can't contain infinity. That was great. Okay, so same question, same type of, not same type of question. We've got a different graph, but we're doing the same type of thing. Part A, we're deciding whether it's a function or not. Yeah, it looks all complicated. Let's grab our vertical line and test it out. So we're going, we're all good. And then right here, some people have said, no, it's not a function because it hits twice. But does it hit twice? No, it doesn't, because one of these holes, one of these circles, is filled in, and the other one over here is not. So it can sweep right through and continue on. And it turns out, when that takes place, it's a function, because it doesn't hit twice. So yes, it's a function, because, and what do we always say? How do we justify whether something's a function or not? Yeah, yes, because it passes the vertical line test. Again. Okay, what? All right, so we're talking about domain. Domain are all the x inputs, and we had a big long discussion about this. The domain of this graph are all the real numbers. Come on, computer. All right, so we had some technical difficulties. The domain are all the x inputs. The domain is, for this particular graph, are all the real numbers. All reals, because you can literally sweep your hand through from left to right, and nothing stops it. You'd think you got stuck right here at 0, but the empty hole over here is filled in by the solid one. So you can actually keep going as you sweep your hand through, and the graph never ends. So the domain is all the real numbers. Another way of saying that is that it goes from negative infinity to infinity. Okay. So the range on this bad boy is real difficult, real difficult. What are some ideas for what the range is? Ooh, that is one way of doing it. Very, very creative. So a classmate said, okay, well, one way to describe what the range could be is that it's all the reals except the x values between, let's see, less than 1 and greater than or equal to negative 1. And that's one way to describe it. All the reals except for the x values between 1 and negative 1. Ooh, not the x values. We made a mistake. The y values. Y values, because the range is always the y values. What's another way to describe the range? Idea. So another suggestion was that in this particular problem for the range, we could basically break it down into two separate problems. The first part being the top over here, right? How do you describe that in terms of the range? Well, all the y values have to be greater than or equal to negative 1. In other words, oops, let's write our other way. Or y has to be greater than or equal to 1. And then since we're going to break it up into two separate problems and put them together, we're going to use this symbol right here, the union symbol, unioned with the idea that, taking a look at the other problem, y has to be less than negative 1. And finally, the third way that you could write out the range for this particular problem is you could use the idea that we just did, but write it in set notation. The fact that, well, the range is from -infinity to -1, soft bracket, unioned, hard bracket, 1, all the way up to +infinity.